Fieldbus. A Fieldbus is an all-digital serial two-way multi-drop communication system. All digital, 100% digital. Serial two-way, incoming and outgoing. Multi-drop communication system. Tapping, we can take that. H1 31.25 kilobits per second. Interconnects kbps, interconnects field equipment, sensor, actuator, IOs. HSE high speed Ethernet 100 Mbps provides integration of high speed controllers, subsystems via linking device and data servers and workstations. Here IO device, this is high speed Ethernet 100 Mbps programmable logic control PLC here connected, linking device, plant and factory, workstations. This is workstations, PLC. That is from the plant factory, here from sensor, this is the field equipment. From here, sensing, getting information in this HSE high speed Ethernet UPS. Then PLC connected. PLC to workstations connected. Integrated architecture. Management information systems. MIS. Management for M. I for information. S for systems. Enterprise resource planning. ERP. E for enterprise. R for resource. P for planning. Enterprise resource planning. And then human machine interface, HMI, that is human plus machine interface, human plus machine. Here from the enterprise resource to be planned, that total management connected by information systems. Last one, Fieldbus information via data servers. Fieldbus information via data servers. Here, same linking device, plant factory, workstations, PLC, HSC, H1, IO. H1 Fieldbus. This is Fieldbus. H1 is the Fieldbus. HSC network. In between this H1 Fieldbus and HSC and high speed Ethernet, factory plant instrumentation and control devices up to here. Okay. Here MIS, ERP, HMI, business enterprise and plant applications package. Here H1, this one here, H1 Fieldbus HMI, H1 HSC network, HSC network, this one high speed Ethernet. Multiple variables, that is here we are going to discuss H1 overview. Multiple variables. Fieldbus allows H1, that H1 means Fieldbus only. So in the Fieldbus allows multiple variables. Fieldbus allows multiple variables from each device to be brought into control system for achieving trend analysis, process optimization, reporting, predictive maintenance, and for assist management. Multiple variable means pressure, flow, how much flow, pressure, temperature, and etc. Fieldbus distortions free characteristics digital communication enables improved control capability which can improve productive yields. Fieldbus distortion free characteristics digital communication enables improved control capability which can improve productive yields. Here, this is sensor side, actuator, control valve, pressure indicator, etc. etc. From here, IO system. Then here analog controller connected to analog controller, that is 4 to 20 milliamps. 4 to 20 milliamps analog controller. This one will connected to control system network, then SCADA and DCS. Here this is traditional 420 to 20 milliamps and on and off one variable, one direction, one, 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 one. Here field bus multiple variables both directions. In one field bus connected all these pressure switch, control switch, actuator and etc. Here individually IO system connected, each one. That's why here traditional 4 to 20 milliamps and on and off one variable, one direction. Here field bus multiple variables both directions, so all are connected in this field bus, that is H1. PV mode variables, alarm, diagnostics and etc. And then here connected to field bus controller. Field bus controller. So after that high speed Ethernet, then system connected. Here analog controller is in, here field bus connecting, here IO system connecting, here that is H1 only, field bus only. That's all. Your IO system input, then output. That 4 to 20 milliamps system. And then diagnostics. Self-diagnostics and the communication capabilities of microprocessor based field bus devices helps reduce downtime and improve plant safety. Plant operation and maintenance of personnel can be notified and corrective actions taken quickly and safely. Self-diagnostics and communication capabilities of microprocessor-based Fieldbus devices helps reduce downtime and improve plant safety. This is a very important point here. Microprocessor, what is having self-diagnosis and communication capabilities. We based Fieldbus devices, H1 helps. That's why it is reduces the downtime and improve the plant safety. Plant operation and maintenance personnel can be notified and corrective action taken quickly and safely. So your time is very important, very quickly. So traditional 4 to 20 milliamps view stops at the IO subsystem. Everything connected, all the equipments, all the instrumentation, all the pressure switch, all the transmitter, flow transmitter, all the actuator, control valves, all are connected to IO system here. From this IO system, 4 to 20 milliamps via connected to this analog controller. Pressure variable. Then it is connected to control system network. Control system network connected to this system. Then from here monitoring DCS, otherwise SCADA, anything you can say. Here Fieldbus extends View to field instrument. Fieldbus extends view to field instrument connected to in the H1 fieldbus. Flow transmitter, pressure switch, pressure transmitter, actuator, control, pressure switch, etc. PV mode, variables, alarm, diagnosis, etc. Here. Field-based control. Then high-speed Ethernet. Then system connected. After that. Control strategy. What is the control strategy? Standard functional blocks is used to implement the control strategy. Standard function blocks. Standard function blocks. This is the standard function blocks used to implement the control strategy. For control strategy purpose, many control system functions such as AI, PID, and AO can be performed by the field device through the use of these standard function blocks. Many control system functions such as AI, analog input, PID, and then AO, analog output, can be performed by the field device through the use of the standard function blocks. Distribution of control into field devices can be reduced the amount of hardware and cabinet footprint needed. Standard function blocks used to implement the control strategy. Many control system functions such as AI, PID, AD, AO, analog output can be performed by the field device. Can be performed by the field device from here. Okay, performed by the field device through the use of the standard function blocks. This is the function block. Distribution of control into field bus into field devices can reduce the amount of hardware and the cabinet footprint needed. So due to this, here itself analog to analog input, analog output, PID, everything connected. For this reason, amount of hardware, reduced amount of hardware and the cabinet footprint needed. That's all. H1 physics. Multi-drop, that is field bus. H1 means here field bus. Multi-drop wire pair with power and signal on the same cable. Multi-drop with wire pair with power and signal on same cable. Multi-drop wire pair. In this multi-drop wire pair, power and signal on the same cable only. No need to separate cable. Support intrinsic safety. Intrinsic internal safety also is there. Functional blocks built into field devices. So functional blocks built into field devices. Functional blocks built into field devices. Control on the wire single loop integrity. Distance up to 1900 meters. Add repeaters to extend greater than 1900 meters. Maximum of 4 repeaters can be used to a maximum distance of 9500 meters. Add repeaters to extend greater than 1900 meters. Maximum 4 repeaters can be used to maximum distance of 9500 meters. In x-axis time, y-axis voltage, field bus signal here. Power 9 to 32 volts.